Welcome to Atlantic Cape Community College's annual Stormwater Training for Facility Staff. The New Jersey Department of Environmental Protection's Municipal Stormwater Regulation Program was developed in response to the U.S. Environmental Protection Agency's rules published in December 1999. NJDEP issued its rules on February 2, 2004, and developed general permits for municipalities, highway agencies, and public complexes that discharge stormwater from storm sewer systems. Public complexes include certain large public colleges, prisons, hospital complexes, and military bases. Atlantic Cape's Mays Landing campus is a public complex and operates under an R11 stormwater general permit. This training for facilities staff is required by the general permit. The following are some common acronyms we're going to be using in this course. BMP, or Best Management Practices, are structural, vegetative, or managerial practices used to treat, prevent, or reduce water pollution. Small MS4 are small municipal separate storm sewers. The word municipal refers to a unit of local government, like a borough or a township, but in our case, it also refers to an organization responsible for the administration of a developed area. And the number 4 refers to the 4 words that start with the letter S, separate storm sewer system. SPPP, or Stormwater Pollution Prevention Plan, is the written plan required by the permit that describes how the permittee will implement each permit requirement and provides a place for record keeping and documenting when permit requirements are met. In addition to stormwater, Atlantic Cape is authorized to discharge the following non-stormwater discharges into and from its MS4. Potable water line flushing, uncontaminated groundwater, air conditioning condensate, irrigation water, flows from springs, riparian habitats, etc., sidewalk, driveway, and street wash water, flows from firefighting activities, and flows from clean water rinsing of equipment and vehicles used in the application of salt and de-icing materials. Prior to rinsing, all equipment and vehicles shall be cleaned using dry methods, and recovered materials are to be returned to storage. Rinsing equipment is limited to exterior, undercarriage, and exposed parts and does not apply to engines or other enclosed machinery. For more specifics about non-stormwater discharges that are allowable under the permit, please refer to the permit. Herbicide application management. The permittee shall restrict the application of any herbicide to prevent it from being washed by stormwater into the waters of the state and to prevent erosion caused by devegetation as follows. The permittee shall not apply herbicides on or adjacent to storm drain inlets, on steeply sloping ground, along curb lines, and along unobstructed shoulders, and the permittee shall only apply herbicides within a 2-foot radius around structures where overgrowth presents a safety hazard and where it is unsafe to mow. Please note, herbicides are defined as pesticides under the New Jersey Pesticide Control Code NJAC 730. While the permit allows for the use of herbicides with the conditions stated above, it is not an authorization circumventing NJAC 730. Any pesticide application must also comply with the code. Permittees are required to develop a stormwater management program to implement BMPs and other measures to reduce the discharge of pollutants from MS4s, maintenance yards, and other ancillary operations to the maximum extent practicable. They must also develop, update, implement, and maintain a written SPPP. The permittee is also required to designate a stormwater program coordinator who has overall responsibility for the operation of the permittee's stormwater facilities or environmental matters at the public complex and is responsible for implementing the stormwater management program. The SPPP must contain written descriptions of all components of the stormwater management program. What we will be discussing specifically in our employee training are stormwater facilities inspection and maintenance, mapping outfall pipes and stormwater facilities, catch basin and storm drain inlet operation and maintenance, maintenance yards and other ancillary operations, street sweeping, outfall pipe and stream scouring inspections, and illicit connection inspections and investigations, and regulatory mechanisms. Atlantic Cape's stormwater facilities consist of multiple catch basins and conveyances, 5 mapped outfalls, 5 infiltration, detention, and retention basins, 3 biobasins, and 2 green roofs. A catch basin is a box that's set into the ground below grade at a low point in a property with a grate on the top and a drainage pipe that slopes away from the basin. Catch basins help maintain proper drainage and catch debris, which prevents pipes downstream from becoming clogged. An outfall is the discharge point of a waste stream into a body of water. Detention basins temporarily store stormwater runoff. They have an outlet and are designed to manage stormwater runoff by storing it and releasing it gradually until it's drained. The permit requires that the basin drain within 72 hours. Infiltration basins, also known as recharge basins, are designed to infiltrate stormwater through permeable soils into the groundwater aquifer. It typically does not have an outlet, does not release water except by infiltration, and should drain within 72 hours. Retention basins are designed to permanently hold water. Biobasins and green roofs are considered green infrastructure. Green infrastructure uses vegetation, soils, and other elements and practices to restore some of the natural processes required to manage water and create healthier urban environments by providing wildlife habitat, flood protection, cleaner air, and cleaner water. The terms catch basin and storm drain can be used interchangeably. Here is an example of a typical storm drain or catch basin you might see on Atlantic Cape's campus. Labeling is required, and if you notice, this one says only rain down the drain as a reminder that these do discharge to waterways, and the only thing that should be allowed to go into these storm drains is stormwater. This is the infiltration or detention basin by the Rutgers building at the Mays Landing campus. It's designed to drain within 72 hours. Remember, detention, dry. The basin should be dry most of the time unless it's raining. This is the retention basin over by M building. It's a retention basin, so it's designed to retain water and mimic a natural pond. It only discharges during very extreme conditions. Many times you can find frogs and turtles in these retention basins, sometimes even fish. These are the biobasins located between the STEM building and the library. They're designed to infiltrate and recharge the aquifer. Biobasins are considered green infrastructure. This is an example of a typical green roof. It's designed to lessen the stormwater runoff from impervious surfaces and return water to the environment through plant uptake and evapotranspiration. Atlantic Cape has green roofs on the STEM building and the G buildings, and green roofs are considered green infrastructure. We're now going to watch a video developed by NJDEP on stormwater facilities inspection and maintenance procedures.
This stormwater management training is a continuation of the material covered in Part 1. This training provides a holistic view of the maintenance work that ensures the stormwater BMPs function well. This part of the training covers 3 topics. The first topic, maintenance of stormwater BMPs, provides the elements of maintenance and the tools to assure the maintenance is properly performed. The second gives an example of using a checklist to inspect a BMP. The final topic provides several examples of commonly occurring maintenance issues. Now let's talk about the maintenance work. As previously mentioned, the purpose of maintenance work is to ensure the stormwater BMPs function as designed. For example, the inlet of a basin must be clear of obstacles such as vegetation, trash, and sediment so that the runoff can freely flow into the basin and get treated. These are some examples of good maintenance on the inlets of NJDOT's stormwater basins. However, it's not always sunny here in New Jersey. It has to rain sometime. Here are a few examples of inlets in bad condition. These can be easily fixed by clearing the sediment, the trash, and vegetation. However, the quick fix will not always be the best way to keep these bad conditions from reoccurring. We need a long-term, consistent way to prevent these bad situations. So, what is the best way to fix a bad situation? The fix is best remembered as Miami. This acronym stands for Maintenance Plan, Inspection, Actions, Preventative Action, and Correction Action, Maintaining Records, and it is an iteration that you have to evaluate annually for the effectiveness of the maintenance plan. Miami is required by the stormwater management rules under which all major development is required to have a maintenance plan for stormwater BMPs. The next slides will explain Miami. The first M of Miami stands for Maintenance Plan. The stormwater management rules at NJAC 7:8, subchapter 5.8, and so forth, spell out the components of a maintenance plan. It is basically a planning and tracking tool containing subplans, including inventory of the stormwater BMPs, information about the stormwater BMPs, planning of preventive and corrective maintenance actions, planning of the logistics, planning of the disposal methods, planning of the costs, and education of staff for training on safety procedures and maintenance work. It can be basically grouped into 3 areas: information, planning, and education. To make it easy to remember, you can think of it as pie. Basically, making a maintenance plan is as easy as making a pie. First, the maintenance plan needs to have an inventory of all BMPs, including the type of BMPs, sand filter, wet pond, their location, located by GPS references or state plane coordinates, and their outfalls. Second, the maintenance plan needs to provide detailed information of each BMP present. The detailed information includes their design information, such as the depth of the basin, the depth of the pond, the number of inlets, the size of the outlet orifices, the design detention time, the drain time, the material comprising the basin bottom, whether vegetation is required, etc. Also, the maintenance plan shall include as-built plans, soil log reports, field testing data, and the manufacturer's warranty and operation and maintenance manual for specific machines or manufactured treatment devices. Third, the maintenance plan shall have plans for preventive and corrective maintenance tasks. We will talk about those later. Also, the frequency and schedule of the maintenance tasks are required. For example, the basin may need to be inspected quarterly, and the sand layer of a sand filter may need to be replaced every 2 years. Fourth, the maintenance plan shall have a plan for the logistics required to perform maintenance tasks. It includes what type of maintenance personnel and the skills required to perform the tasks, and the equipment, tools, and supplies needed to do the work. You may think that the maintenance yard already has everything you need, but it is easy to overlook some crucial element in the planning of logistics. Let's take a look at what tools and equipment you may need to maintain stormwater BMPs. Here we list some of the tools and equipment needed to perform maintenance work. Some of them are common items, such as a lawnmower, pry bar, shovels. However, some of them are less common, such as a vacuum truck and a lightweight backhoe. Well, why do we need a vacuum truck? Some types of MTDs have a sump or collection area at the bottom to store settled solids and debris, and the opening of the MTD may be too small for a person to climb inside to dig out the collected material. Therefore, you will need a vacuum truck to remove the sediment with suction. Also, why do we need a lightweight backhoe? As previously mentioned, soil compaction must be avoided in infiltration basins. Therefore, when you replace sand or regrade the soil of the infiltration basin, you must use a lightweight backhoe to do the work. A maintenance plan also needs to include the disposal method and the cost. The disposal method has to consider how to transport the removed vegetation and sediment to the disposal site. Measures may be necessary to prevent leakage of wet sediment during transport, and the site may be municipal or privately operated, or in some cases involve on-site disposal. Since permits are often required for disposal at these facilities, it is essential to plan ahead for the costs, the time, and the tasks associated with obtaining these permits. After planning the tasks and subjects mentioned above, you will have an estimate of the costs involved, which are always required for budgeting purposes and for compliance with the stormwater management rule. A maintenance plan shall also include a plan to educate and train staff regarding safety procedures and measures, especially the safety procedures for confined space entry. The maintenance plan shall also set up a training schedule for maintenance staff on the stormwater BMPs, maintenance work, use of tools, operation of equipment, and record keeping of performed tasks. To recap the maintenance plan, what components are required? Basically, making a maintenance plan is as easy as remembering the word PI, which is short for planning, information, and education. The planning part of a maintenance plan includes planning of preventive and corrective maintenance actions, planning of the logistics, planning of the disposal method, planning of the costs. The information part of the maintenance plan includes inventory of the stormwater BMPs and information about the stormwater BMPs. Lastly, the education part of a maintenance plan includes education of staff on safety procedures and elements required to perform maintenance work. The next step in the solution is the I of Miami, which stands for inspection. Regular inspections of the stormwater BMPs help us discover problems before they evolve into big issues. As seen in the photos of poor conditions at basin inlets, one may wonder when those inspections had last been conducted. Another acronym may help us remember what an inspection entails. It is the word SECOND. The stormwater management rules and the BMP manual require regular inspections and records of those inspections. However, before we hit the road to perform an inspection, we should consider how we will do them in a way that is systematic, effective, and correct. A permittee may have many basins to manage. Therefore, a tight schedule may be necessary if we are to inspect all of the basins in a timely fashion. Furthermore, we do not want to have a dispute about whether or not an inspection had been conducted, nor what problems were found in that inspection. Therefore, we want the problems that were discovered to be followed up on and actually resolved. Therefore, we need a written way to keep track of everything. All of these considerations can be addressed by using an inspection checklist, which lists the items to be inspected, tells us how to check, and provides a space to record the problems plus other important information, such as the weather on the day of the inspection, who was present, etc. It is worth noting that each type of BMP may have different items to check. An obvious example is that inspections of a wet pond will differ greatly from those of a sand filter. NJDEP has developed an inspection checklist for each of the commonly used BMPs. We will talk about them later. After the inspection, what is the next part of maintenance? The actions. They include preventive maintenance tasks and corrective maintenance tasks. Preventive action is geared towards housekeeping done on a regular basis. The corrective actions are more likely to occur incidentally in response to the problems discovered during the inspection. Here is a list of preventive actions and also of corrective actions. It is by no means a full list. The actions could be more depending on the type of BMPs and the variation of the design. For example, the sand layer of a sand filter or infiltration basin needs to be replaced at least once every 2 years. However, if these BMPs are located in an area of having high solids loading, the designer of the BMP may request a more frequent replacement of sand. The next part of maintenance work is to maintain good records of the inspection, the preventive actions, and the corrective actions taken to date. Keeping those records are also required by the stormwater management rules. Practically speaking, it is good to keep those records for tracking down whether or not the issues have been resolved, finding a trend, or tracking how an issue evolved, and providing as evidence the work was actually performed. The maintenance records serve as a searchable archive of the inspections and the resulting work orders for preventive actions and repairs. Finally, the maintenance work is an ongoing, evolving process. The stormwater management rules require that the effectiveness of the maintenance plan be evaluated annually. The maintenance plan must be adjusted according to the resulting evaluation. Maintenance personnel shall provide comments and suggestions to the manager for consideration on how to perform the work more effectively in the future. The manager shall also review the inspections and preventive and corrective records to find whether an improvement can be made. Up until now, we have talked about the need for a maintenance plan to lay out the maintenance tasks. We also talked about the inspections, the preventive actions and corrective actions, and the maintenance of records. One may wonder who has to prepare the maintenance plan, who performs the inspection, and who keeps the records. So let's talk about roles and responsibilities. Under the stormwater management rules, it is the design engineer's responsibility to prepare the maintenance plan because he or she is the one who best understands the requirements of the BMP design. The design engineer also has the most knowledge of all of the site conditions specific to that BMP, such as the water table, the soil, and the drainage area, etc. However, if the design engineer did not properly prepare the maintenance plan, or if the maintenance plan has been lost, the responsibility to prepare the maintenance plan may fall on the responsible party, who is typically the operator or the owner of the facility. Often a permittee will be the responsible party unless it is assigned others this responsibility. The day-to-day performance of the maintenance task falls on the maintenance managers and the maintenance crew, with each having various responsibilities. For the inspector, it is a role that can be performed by people inside the responsible party. But sometimes the inspector may be from a local authority, such as township inspectors, or from state agencies like the DEP. Let's look at an example of the checklist that the DEP has been developing as part of a series of field manuals for the maintenance work of specific BMPs. Each field manual includes the information about the specific type of BMP, visual aids for conducting maintenance, and an inspection checklist specifically tailored to that type of BMP, and the records for preventive and corrective actions. It is a template that the design engineer or the maintenance manager can change to meet the needs of their stormwater BMPs. The maintenance crew can take one field manual to do an inspection and record maintenance work every time they go out. They can read the information about the specific stormwater BMP they are going to inspect or work on. Then they can record the inspection findings, maintenance work, or repair work performed on the checklist and keep the maintenance record in the field manual. After coming back to the office, they can hand over the field manual to the manager, who can then track down the issues and keep the inspection checklist and maintenance records in the file. Here is a look at an Infiltration Basin field manual. The cover is the information needed to locate the BMP. The next page is the design information regarding the dimensions of the BMP, the expected drain time, and special requirements such as a sand layer or vegetation. Then, there is the checklist for inspection. On the checklist, the inspector may record site information such as the weather, the ground condition, wet, dry, ponding, present. Then the checklist includes inspection items grouped by the major component of the BMP, such as the inlet, the basin bed, the embankment, the outlet, and vegetation, etc. It also has the instructions of what conditions are determined to be normal and the space to make comments and assign work orders for corrective actions. Then the inspector can sign off on the inspection form and include a date. The field manual also contains the preventive maintenance record and the corrective maintenance record. The maintenance personnel can record the work performed and any issues to be followed up on. Now let's see some photos of some common maintenance issues and how to correct them. Recall that in previous slides, we categorized the grass swale as a vegetative type BMP, which must be dry and have good vegetative cover. These three photos show ponding problems, which has caused a loss of vegetation in all or some part of the grass swales. To fix this, it is essential to find the cause of the ponding. If the outlet is clogged, remove the clog first and determine if the grass swale will dry up. If it is still ponding, it may be necessary to also check whether excessive sediment is making it difficult for water to flow. Also, revegetation of the area will be needed. This is an infiltration basin that became a permanent impoundment. It has not rained during the past 72 hours, therefore that basin should be dry. However, this photo was taken during winter time. It may be necessary to recheck at a later time if the ground is frozen. So neglecting the frozen conditions, how do we fix it? We could pump and remove the standing water, check the condition of the basin bottom and the water table. If the water table is low, we could replace the soil or the sand layer of a basin bottom. The permeability and depth of replacement soil and sand must match the original design. However, if the ponding is caused by a high water table, we may want to check the original design and the soil logs to further evaluate the original design. We may need to retrofit the infiltration basin to another type of BMP that does not need to infiltrate runoff into the ground. These two photos show a detention basin with a low flow channel. The trash racks to protect the low flow orifice are entirely clogged by debris and vegetation. The easy solution is to remove the debris and vegetation, but it may be necessary to conduct more frequent inspections and perform preventive actions more frequently to keep the trash racks clear. These two photos show trash racks of a detention basin that has been damaged. Corrective action is necessary to affix the trash racks to the outlet structures. More frequent inspections may be necessary to check if it has fallen off entirely. These two photos show problems at wet ponds. Algae blooming is one common problem of wet ponds. Aeration of the pond and removal of the algae from the pond may be needed. The bottom photo is a breach of a wet pond. A corrective action to repair the breach is needed. However, a more frequent, regular inspection may have discovered erosion and cracks in the embankment before it became enlarged. Let's summarize the presentation regarding maintenance of stormwater BMPs. In Part 1, we talked about the reasons we need stormwater management and the basic functions and types of stormwater BMPs. For the basic functions, they include pollution control, flood control, and erosion control. Also included is groundwater recharge. The types of stormwater BMPs, which we've categorized for the purpose of maintenance, include the dry basin type, the wet basin type, the vegetative type, and MTDs, which are manufactured treatment devices. In Part 2, we then talked about the required maintenance of stormwater BMPs. The Miami solution, which is the maintenance plan, inspection, action, both preventive and corrective, the maintenance of records, and the iteration of the maintenance work. For creating a maintenance plan, it is as easy as making a pie. Information about the BMPs, planning of the maintenance work, and education of the personnel. We also gave an example of a checklist, which addressed maintenance records and the items that one would have to record about a particular BMP during a site visit. Finally, we talked about some maintenance issues and how to fix them. Thank you very much for your attention. If you have further questions or require assistance, you may reach out to the DEP's Stormwater Management Unit and feel free to contact any of us. Elizabeth Dragon is the unit leader. There's also Titus Magna, Adriana Caldarelli, Lisa Schaefer, Jingyi Wu, Corey Annan, and Armando Alfonso. Our phone number is 609-633-7021, and here's our website information. In fact, if you'd like to see njstormwater.org, this is what the website currently looks like. Thank you again.
We're going to watch a short video on maintenance yard operations. It will include information referring to Tier A municipalities. Please note that the requirements for an R11 public complex are the same as outlined in the video.
Maintenance yard operations. Many of the day-to-day operations at municipal maintenance yards can contribute to stormwater pollution when these operations are not managed properly. The permit requirements for maintenance yard operations are aimed directly at the municipal public works yard and their ancillary operations. Best management practices have been designed to help improve the quality of stormwater leaving the maintenance yard. Where and how vehicle maintenance is performed, maintenance materials are stored, and motor fuels are handled can all directly impact the quality of stormwater leaving these sites and entering our water bodies. Municipalities are required to implement standard operating procedures for the following activities: vehicle and equipment fueling and bulk deliveries, vehicle maintenance, good housekeeping, fueling operations. Tier A municipalities are required to implement a standard operating procedure for all vehicle and equipment fueling as well as bulk fuel deliveries. All maintenance yards and ancillary operations which have gasoline, diesel, heating oil, or waste oil are applicable to this requirement. The maintenance yard and supporting facilities must be inspected regularly to ensure compliance with the municipality's fueling operations standard operating procedure. Remember to document your inspections. General fueling requirements include no topping off vehicles, mobile fuel tanks, and storage tanks. Perform regular inspections and maintenance on all fueling equipment. Clearly post in a prominent area of the facility instructions for safe operation of fueling equipment and appropriate contact information for the persons responsible for spill response. Any equipment, tanks, pumps, piping, and fuel dispensing equipment found to be leaking or in disrepair must immediately be repaired or replaced. Bulk fueling operations. In addition to general fueling requirements, special procedures must be implemented during all bulk product transfers. A bulk product transfer includes delivering gasoline, diesel, or heating oil to and removing waste oil from a maintenance yard or ancillary operation. A trained employee must always be present to supervise the bulk fuel transfer. Drip pans must be used under all hose and pipe connections and other leak-prone areas during bulk transfer of fuels. Block storm sewer inlets or contain tank trucks used for bulk transfer with temporary berms or temporary absorbent booms during the transfer process. If blocking storm drain inlets will not permit the containment of a spill on site, then temporary berms or booms should be used. If temporary berms are being used instead of blocking the storm sewer inlets, all hose connection points associated with the transfer of fuel must be within the temporary berms during the loading, unloading of bulk fuels. Discharge of stormwater from secondary containment. Stormwater often collects in the secondary containment devices associated with many gasoline, diesel, and waste oil storage tanks. This collected stormwater may be impacted by the day-to-day drips and spills which can accumulate in the secondary containment. Only clean rainwater which shows no visual sign of petroleum impacts can be discharged from secondary containment devices to the environment. The NJDEP requires that the discharge pipe for the secondary containment device remain closed at all times prior to a visual inspection for petroleum impacts. Inspections for sheen should be documented. For the inspection and release of stormwater from secondary containment associated with materials that may not liberate a sheen or other visual indicators of contamination, analysis of the accumulated water may be required prior to releasing to the environment. If it is determined that stormwater has been impacted by the substance, the mixture must be disposed of by a licensed waste disposal contractor. Vehicle maintenance. Tier A municipalities are required to develop a standard operating procedure for vehicle maintenance and repair activities. The maintenance yard and supporting facilities must be inspected regularly to ensure compliance with this standard. At a minimum, municipalities must ensure that all vehicle and equipment maintenance is performed within an indoor location on an impermeable floor whenever possible. For projects that are too large to be performed indoors and last more than a day, the equipment must be covered when not being serviced, and drip pans must be used. Many times, floor drains are placed in mechanic maintenance areas at public works garages. It is important to confirm the discharge point of these floor drain systems. When possible, floor drain discharges should be routed to the sanitary sewer system. Floor drain systems that discharge to the environment without a separate NJDEP permit, even if treated through an oil-water separator, are considered illicit connections and must be eliminated within 6 months of discovery, in accordance with the requirements of the municipality's Illicit Connection Elimination Program. Good housekeeping. Tier A municipalities must identify all sources of potential stormwater pollution at their DPW yards and implement procedures to reduce the exposure to these materials to stormwater. An inventory of all general categories of source material present at the maintenance yard and all ancillary operations must be included in the municipality's stormwater pollution prevention plan. Source materials include, but are not limited to, construction materials, used parts and tires, rimmed or unrimmed, equipment and fuels, hydraulic equipment such as snowplows, oils and greases, solvents and detergents, fueling areas. A rule of thumb for determining if materials such as equipment and parts can impact stormwater is to simply wipe the surface. If residual material transfers to the cloth or your finger, it is likely that the material will be removed by precipitation. Municipalities should conduct regular inspections for any potential source material present at the maintenance yard or ancillary operations. These documented inspections should include what steps were taken to remove, cover, or eliminate the source material in question. Good housekeeping practices must include the following activities. Container management. Properly mark or label all containers. Labels must be kept clean and visible. All containers must be kept in good condition and tightly closed when not in use. When practical, containers must be stored indoors. Containers may be stored outside as long as they are covered and placed on spill platforms. Empty drums must be closed to prevent stormwater infiltration and wiped clean of all residual on the exterior. Spill cleanups. Conduct cleanups of any spills immediately after discovery. Clean all maintenance areas with dry cleaning methods only. Spills shall be cleaned up with a dry, absorbent material, such as kitty litter, sawdust, etc. This material should be swept into the area and removed immediately. Leaving this material on the spill site will allow stormwater to carry it into the environment. Collected waste is to be disposed of properly. Cleanup materials, spill kits, and drip pans must be kept near any liquid transfer areas, protected from rainfall. Equipment and vehicle washing. The uncontrolled washing of municipal vehicles and equipment has the potential to deliver large amounts of oils, greases, and solids to receiving water bodies. The Tier A stormwater permit allows wash waters from vehicle and equipment washing to discharge to the environment until February 28, 2009. The rinsing of de-icing vehicles and beach cleaning vehicles following a dry sweeping is included in the list of allowable discharges in the Tier A permit and will continue to be permitted after this date. Municipalities should consider utilizing commercial washing facilities, installing a vehicle wash system, or using regional vehicle washing facilities following the 2009 permit modification. Residential car washing is allowed. However, we should urge our residents to use commercial car wash facilities whenever possible. De-icing materials storage. Each winter, thousands of tons of salt and other materials are used on roadways all over the state of New Jersey. Many municipalities store large volumes of salt and sand at their maintenance yard for use on municipal roads. The safety benefit from the use of these materials outweighs its impact. However, municipalities must minimize the exposure material while stored on site. Significant environmental damage can occur if large amounts of de-icing material are allowed to impact a single water body near these bulk storage locations. Groundwater, surface water, and local wildlife can all be negatively impacted by large amounts of salt entering the environment. Tier A municipalities must construct a permanent storage structure for roadway de-icing materials by April 1, 2007. In the interim, seasonal tarping of de-icing materials is an acceptable practice from October 15th to April 30th. The material must remain covered at all times when not actively being used. Clean sand does not need to be kept covered, but must be stored 50 feet from any storm sewer inlet, stormwater conveyance channel, or water body. The permanent storage structure must be fully roofed, walled, and anchored to a permanent foundation with an impermeable floor. Structures must also contain an enclosed entrance to provide adequate protection from directional rain and spill out. The structure should prevent stormwater from impacting the stored materials. Required good housekeeping practices for de-icing material handling have been detailed in the Tier A stormwater permit. Prevent and/or minimize the spillage of salt and de-icing materials during loading and unloading activities. Use dry cleaning methods for spilled salt and either reuse or properly discard. Sweeping by hand or mechanical means of storage and loading, unloading areas shall be done on a regular basis. More frequent sweeping is required following loading, unloading activities. Sweeping shall also be conducted immediately following, as practicable, loading, unloading activities. Tracking of materials from storage and loading, unloading areas shall be minimized. Minimize the distance salt and de-icing materials are transported during loading, unloading activities. Regularly inspect your permanent storage structure for damage. Repair damage in a timely fashion.
There are just a few items to remember that are specific to Atlantic Cape's Stormwater Pollution Prevention Plan. Vehicle washing must only be conducted at a commercial car wash station unless the wash water is collected and managed as wastewater. Nothing other than sanitary wastewater can be discharged into the I-building septic system. All catch basin refuse stored on site should be covered from precipitation and kept on an impervious surface until it is disposed of by a licensed solid waste transporter at a facility properly permitted to accept solid waste. Water leaching from catch basin refuse should be managed as wastewater and should be disposed of into the sanitary sewer or through a licensed wastewater disposal contractor. Again, to reiterate, clean water rinsing of equipment and vehicles used in the application of salt and de-icing materials is allowed. Prior to rinsing, all equipment and vehicles shall be cleaned using dry methods, and recovered materials are to be returned to storage. Rinsing equipment is limited to exterior, undercarriage, and exposed parts and does not apply to engines or other enclosed machinery. Conduct cleanup of any petroleum or chemical spills immediately after discovery and by using dry cleanup methods only. All contaminated spill cleanup materials will be disposed of in accordance with Atlantic Cape's Hazardous Waste Management Plan. Any spill should be reported to your supervisor and security immediately, who will contact NJDEP or US EPA as appropriate. Call 911 first in the event of injuries, fire, or explosion. If a person is in immediate need of medical care, call 911, then security. If you come upon an unconscious person, do not attempt to rescue the person or administer care if you are unsure if it is safe to enter the area. All street sweeping waste material and catch basin refuse stored on site should be covered from precipitation and kept on an impervious surface and disposed of as a solid waste by a licensed solid waste transporter and taken to a facility permitted to accept the waste. The permit requires that Atlantic Cape develop an outfall pipe inspection program. This permit condition has three components: outfall pipe mapping, illicit discharge detection, and stream scouring detection and control. Attached is a map of Atlantic Cape's stormwater management system. Green roofs are highlighted in purple. Basins are circled in red. Outfalls are circled in blue, and biobasins are circled in green. This diagram illustrates common illicit connections. Illicit connections can be caused by plumbing cross connections, polluted stormwater runoff getting into the storm sewer system, or illegal dumping. Here's an example of an illicit connection that occurred at our own campus. Outfall pipe stream scouring is the localized erosion of the stream bank or bottom caused by the discharge from the outfall pipe and can have a negative effect on fish and other aquatic life living in the stream. If scouring is noted, one way to eliminate it is to retrofit stormwater facilities to slow the discharge of stormwater through the outfall. The permit requires permittees to develop regulatory mechanisms to address violations of the Stormwater Pollution Prevention Plan. The regulatory mechanisms must address pet waste control, litter control, wildlife feeding, prohibiting illicit connections, and improper waste disposal. You can find Atlantic Cape's regulatory mechanisms at our website under Policies and Procedures.